How's it going, everyone? Eulier Gonzalez here again, and today we're gonna take a look now at this hard part of JavaScript, especially in the object-oriented programming. But let's gonna take a look now deeper in how subclassing works, why we need to look at subclassings, and from there see how subclassing works using is now the new keyword. How subclassing works using is the old way of actually creating objects, which is using the object.create. Then with the new keyword, what are the things that it automates behind the scenes? And then now with class. But in today's video, we're going to focus our attention is on subclassing with the new keyword and call. Why this is important? As a way to understand how all of this inner mechanism works behind the scenes, just anytime you see a particular code base, you see and you can recognize how this object can have access to all of this data and properties. So that's something beautiful. Because at the end of the day, one of the things of this entire course is to look at how object-oriented programming allows us to write programs that can scale in a professionally engineering environment. And you may wonder, why do we need to take a look at this application that scale? Because just to play devil advocate here, the more you are able to now provide a product at scale, the better off will be not only for your business but also for your customers. So imagine that now, 100 years ago, we barely have access to all of the foods that we have right now. And now, look at this. And not only that, but also in the terms of the access of information, we have now a vast access, something that we didn't have that before. And that's something that has been achieved by the technique, all right, as well as the scalability. So these particular techniques or approach of the object-oriented programming now allows us to build and write these applications that can now satisfies masses. So for example, not only Facebook or Instagrams or your bank account applications, but also to communicate to others, regardless their physical locations. So for example, through WhatsApp or Telegram. And I think this is something powerful. There are detractors that say, hey, you shouldn't do that. It's like you don't know the risk involved in creating things at scales, and what are the challenges, for example, that humans have to face that. I get it. But at the end of the day, most of us like the kind of food that we can have access to. And that is sushi, rice, avocados, something that in your local country or in your country, perhaps that never do the climate change or do the temperature or any of your climate environments is not allowed to actually harvest that. So now, this course is taught by Will Sentence, the CEO of Codesmith, which is a software engineering and machine learning residency headquarters in New York and California. And thanks to the front-end master, now I can have access to these informations, take notes of how now JavaScript with the object-oriented paradigms allows us to write these programs that can scale in a professionally engineered environment. And I really love the word profession because it comes from according to the etymology dictionary, the professions, it comes from Old French that is that stands for vows taken upon entering a religion. Again, our decisions, this life is decision making. Okay, uh, this life is choice driven. Okay, so by recognizing that, and if you dedicate in a particular way, so meaning you commit yourself to a profession and to do something consistently over time, you're not going to only build a reputation, but you're also going to explore things that you perhaps you might never thought about it. So that's one of the things that I really love of the professionals. Okay, as long as you can provide value, which is something hard, it's very very hard, but as long as you can provide value and do that because you love the thing that you do, now you can is be recognized by others, work with others, and collaborate with others toward a particular goal. So in any case, this this residency, it tries to, or the business model is taking all of these people that come from boot camps, okay, and kind of accelerate into senior roles, because after all, that's exactly what the industry is demanding. We need people that can now not only be good enough at moving levers here and there, but also to provide value to customers, to companies, to college, and also for themselves. But in any case, here we now make a quick recap of what are the things that companies and even you should take a look at that. For example, like analytical skill is like how good are you solving your own problems? How is your thinking process? The technical communication is that can I implement your solutions based on your explanation? Also following the good engineering practice. Soft skills, which is something that a lot of people in the industry, they recognize that most of these software engineers, they lack of that, and this is part of the job, this is part of the task that we're going to do here. And lastly is domain knowledge specific, so the language, the specification, the data structure, the algorithm, and that kind of thing. So far so good. Okay, so this course is now outlined in this. So this is the structure of this course. We're going to make a quick recap of all of this until we reach to what we care about, which is subclassing with new and cold. And actually, write it down, how can we do that? And that'll be very, very interesting. So, well, this introduction to object-oriented programming is just as a way to now people in the 60s, they need to find a way to organize data and relevant functionality together into one bundle. So they come out here with this object-oriented programming. So then how can we use object-oriented programming in JavaScript? By building objects. How can we build objects? Glad you ask. We can have several ways to do that, whether it's object literal, dot notations, object.create, as well as creating objects using functions. So the approach of using function, which is the solution one. Now, when you do this, so one of the caveats of this is that, which is a great, is a particular approach of creating object. It's like, hey, this is how you can create object, but anytime you create a new user, for example, let's say you're gonna build this game, ping pong game, all right? You wanna, well, not only know the name of the player and also take score. So here you say, okay, let me now create a new user, which is an empty object here, and then assign some property, and also it is functionality as it is. So when I create Phil with score 1 and Julie with score 5, and then run their functions, this is actually something that works. What is the problem with this? Is that anytime we are creating as a new object, we also is duplicating is the functionality. Functionality that will remain the same. But what's gonna change is the data that we want to apply it to. And that's here when things started to get interesting here. Because now the object-oriented programming is all about how can I make the data to work with relevant functionality and to make it into a one single bundle. Okay. So an alternative or a solution to this is say, well, instead of using this because it's not memory efficient, we're creating its functions over and over and over and over for imagine 200, 1,000 users. So wouldn't be a better way to do that? And that's when we now use is the object.create. So object.create here, what allows us to do is to abstract or put our functions into a different objects. So far so good. So now can we know that this new object that we're creating somehow has a reference or a link to that object's functions of our user. And that's why object.create allows to create that. Because at the end of the day, object.create, once you cast that command, JavaScript will look at the proto and now going to update the proto property, the dunder proto dunder, and it's going to link that to that object, to the object. It's going to link that to the objects that you're passing here. So now this is how you can have access to the property and methods. So this is actually something great. This is also known as the sophisticated way of creating objects. Perhaps you might find this in some very, very, very old code bases. Okay. And one of the downside with this approach is that anytime you create a new object here, you now have to do all of this manually. You have to do all of this handcrafting. So I'm creating is one object here for the user, and then I have to manually set the link for that. So the JavaScript designers, the ECMAScript designers, they say, hey, instead of actually you creating that, which is, there's nothing wrong with that, but as a way to automate this process of now setting is the link for you, so you can have access to all of these property and methods, so you can now have access to the relevant functionality that is going to be applied to the proper data. Remember, this is all about object-oriented programming. Now, let's take a look at how can we do that with a new keyword called new, by the way. So this new keyword here, what it's going to do is to do something in the background as a way to automate that link process. But we need to actually do that in a particular way. So first, we need to define is the function constructor, okay, where we're going to use this value and assign all of the parameters and assign all of the arguments that we're receiving as in this function constructor as parameter, okay, which is part of the solution 3. So we define is the data layer, and then we define is the methods layer, the functionality layer under the prototype. So that's something interesting, because once we are able to define this functionality here attached to the prototype of this function constructor, you may wonder where this prototype came out. After all, remember that in JavaScript, everything is an object. So functions are an object, and a special type of objects. Class, as we're gonna see that later, is a special type of objects. And now, if you take a look at the specification, the functions has a special property called prototype, where this is being used for developers to put functionality in there. So now the functions as an object has this duality, or this combo. This is an object function. So when you now can define your object portion under the prototype property, and you can now call this functions with the function portion, right? So this is part of the design of JavaScript. So with that, okay, now once we know how this function works behind the scenes, where this prototype came from, so when you want to invoke a new, or when you want to create a new object, in this case user, what it's doing behind the scenes is to send the value of setting the new keyword. Do a couple of things behind the scenes. First, it set the value of the this as an empty object, and inside of the function constructors you can add all of the data that you need to, that you receive as parameter in that function. And then under the prototype, okay, the value, the new keyword, what it's doing is, take a look now at the proto, which holds a reference. Every object has this proto reference, the dunder proto dunder. The specification called this as the prototype, and that's just like a more underscore the prototype under double square bracket. The specification actually doesn't make it easy to reason about it, no problem. But we're gonna call here dunder proto dunder because now this is on the in the Chrome DevTools, in Firefox DevTools. That's what it's being called. Good. So first, the new keyword set the value of this, which is something that all of the function contexts already have. Okay, set the value of this. Okay, set the value of this as an empty object. Okay, here's when things started to let it on be quite interesting, because the value of this is something that is gonna change. It has it behaves differently depending on the scenario. So you have several rules here. It's like 7 or 8 rules that they have. So for this context here, when you use the new keyword, you're gonna take a look at the function execution context, set the value of this keyword as an empty object, update now the reference of the proto. It's like to update now the reference of this keyword to point to the prototype's function constructor. Okay, to point to the prototype portion function constructor, function object constructor. Okay, that now you can have access to this property and methods. And lastly, it's going to return the object. So that's something interesting, because with this particular approach, once you understand this, then now we can have our data in this function constructor, and under the prototype, all of this functionality that we need to. What happens when we need, for example, is additional functionality, not under the prototype, but under the method defined under the prototype. So for example, in the increment or in the logging here, okay, as a way to, well, now have much more functionality. For that, we need to know add something interesting in JavaScript. which is the scope and the value of this. So because the value of this has several rules, okay? And one of them is when you're using is a function, when you're creating as a normal function, the value of this will be whatever is on the left side of the dot when it's called. So that might be great, but for example, nested functionality, exactly, but for example, nested functionality like this, when you want to try to access to this value, because now one of the rules of the this value is that if I don't have anything on the left, then the value of this by default will be window. That's one of the really and lovely things, especially when you walk through this kind of diagrams, okay, as a way to now explain how all of this work. And I really love about this, totally, I really love this. So how can we fix that? Back in the old days, actually, people to fix this common problem as a way to work with the relevant data, because at the end of the day, that's what this allows to work, to access to. Hey, we would like to work with the proper data. And now, once we have this, the value of this is actually pointed to something that is not that we wanted. JavaScript behaves that way. So before that, we have people that actually use they define a variable called that as a way to hold this value, which means the relevant data that we want to work. Okay, and then we pass down to the functions using the call or bind or apply. So the subtle difference between the call and apply is that this function accept is the first parameter is the value of this as a way to now provide the proper value of the this, which is great. And they call in on when the function is run. All right, and they follow by, so for example, apply, accept, call accept is parameters as comma separate values, whereas apply as an array. But the other is bind, and bind we want is to now pass is this data, okay, or the proper data that we want to work with. In a way that now we can have access to this, but a definition, okay? So now JavaScript designers, thank God, they say, hey, you know what? It would be better for those cases to use something called the arrow function, because at the end of the day, remember, we care about is the value of this. So these arrow functions, what it's doing to this value is creating a closure here. So if you want now to have access to the outer property and methods, creating an arrow function, what it's doing is that it's creating a closure for that. In other words, the value of this is whatever was written. So it's lexical. It means that I'm here, I was defined here, so I have access to this context. All right, that's a great interlude as a way to how can we now use the value of this and the scope, and how can we extend our functionality here with the prototype here as a way to make sense of the reason of why we are now looking through all of this, okay, as a way to now understand not only how this new key works in class work, but also is to recognize that at the end of the day, we want us to write scalable applications in a professional engineering environment. So now, before actually, and as you can see here, with this particular approach, okay, actually, there is no performance approach with using arrow functions, but it's a trade-off here. It's more in terms of readability that it is. And as you can imagine here, okay, that one of the great things of this is that now we're creating object that their data is unique, and when we want to apply relevant functionalities to this data, we are being memory efficient. So that's actually something great. It's one of the things that you're going to see a lot in professional code. Okay, it's a way to do this, and as you can see, people behind the scene, or the JavaScript designer says they were ashamed of this nature of this prototype nature. So with the class keyword, they just want to look like syntactically as a class object-oriented programming, such as Python or C and C++, most likely Python or Ruby, okay, but without the but behind the scenes is actually using the prototype nature. And the class keyword, what it's doing is that it's making our life much more cleaner and easy to define data, okay, to work relevant data, and bundle it with relevant functionality to this. That's all. So before going into class, we need to know how subclassing works. In other words, how you can have access to other property and methods. Why is this? If you so far we have defined our user as it is, okay? And what if we want to reuse some of our old work? Wouldn't it be great to actually find a way to say, hey, I want you to now access to these methods that I define on this class, and also I want to access to this data that I defined previously, but now I want to cover specific use cases, specific business use cases. So for example, pay users. All right, that's great. So how can we do that? Before that, we're gonna take a little interlude to look at how now the prototype works by default. So for example, when you take a look now at the objects, okay, when you create an object, the proto reference points now to the object constructor prototype, and you can have access to these properties. The functions, because after all, functions are special type of objects which are callable, they also now have this hidden property called proto that points to an object that it can have access to the object functionality here, as well as the functions has its own properties like call, bind, apply to stream, okay. And another good example is the array. So the array objects contains a lot of property from that, okay. Own properties, sort, find, filter, find index by reverse. It contains a huge set of, or it contains a set of functionalities, and then their proto, because after all this is an object, their proto now points is to, because this is a function object, the array. If you take a look now at the array, MDN, okay, the array constructor here, but this is on here. So you can see that I didn't lose my mind, is that anytime you create now is this array 1 2 3 4, let me assign that to a variable called value here. Okay, now is array num, okay, and then you want to access to what is this array num has. So it not only contains this, but also contains another property like length, and under the prototype, which means the reference that it points to, okay, that can have access to under the prototype, it has now access to this objects function here on the array, which is add, concat, constructor, all of this. That's when you can have access to this, but it's through the proto. Okay, so we are now linking to this array objects that contains all of its functionality, and also this array object points to the, which is the, when I mean point is the prototype, which is a bad name here because at the end of the day is the proto reference. Okay, the proto, exactly, it points now to an object, okay, that you can have access to all of this property and methods here, and now the proto, which contains the reference to, in this case, the array. So as a way to now create this link reference, so the proto have now access to the array, and it also contains a proto property here, which is the proto points to an object, okay, and that proto you can have access to the objects here, the property and methods, that this actually will point to null. So that's what is known the proto change. So this, the reason of looking at this is that now we can have access, and if you take a look at this symbol iterator, something that we're going to see that later on the course of async and await, or this asynchronicity, how asynchronicity works behind the scenes, and I think that's very, very, very interesting. Totally. Okay, yep, as it is. But here we are looking now at how the prototype change works, and as a way to that you can have access to all of these objects for that. So some people call this inheritance, but I prefer to call them accessing, because at the end of the day, what you're doing behind the scene is to indicating, hey, I want to access, using the object of create, I want to access to this property and methods. That's all. Under the prototype. So okay, so far so good. Okay, now things slowly to make sense a lot. So now you understand is this daemon, which is after all, it was not a daemon. It was just a thing that you didn't understand how that works behind the scenes. That's all. That's all. So now that we know how the prototype change work by default, okay, now it is time to look at how can we now create or make subclassing with factory functions. So, and that is, well, at the end of the day, remember that we want is to reuse functionality. Or the whole point of this subclassing is that how can I reuse some functionality that I previously defined from other objects to cover this new use case. That's all. So first, we're going to see how you can do subclassing with factory functions, which is looking at the solution 2. And the solution 2, if we remember, is, well, how can now create objects using the object of create, okay? As a way to now have access to that. And let's actually do that here. Let me actually do that here, because I think this is very, very interesting. So how can we now do subclassing with using the object of create, this sophisticated way to create objects? Glad you asked. So here is going to define is our user, okay? The user here that, okay, here we're going to define is the function user creator. What we're going to receive is the name and the score here, okay? And then here we go now to create a new object here, which is the user, using the building object to actually create that reference to point to our user function, where in our case it'll be like this. We define this like here, remember, to point to an object. So we define here as user functions, okay, where this is an object that will contain is now the increment, okay, as a function. We are using now this keyword because anytime we call this function, I want to have access to the relevant data, in other words, to whatever is on the left side, which means is using the this, and let's say score. No, it's going to increase the score here. Score. So I didn't have this functionality, or I don't have this property defined here, okay? So let me now referencing to this user function like this, and below that create is the property that this object will have, that this user will have, which is the name, followed by the name, as well as the user dot score, right? And then, well, return that object, which is user. Let's go to add some extra functionality here. Let's say login, okay? And I want you to say, hey, this is function. This function, the only thing that you're gonna do is just to console log this functionality. Okay, say, hey, you're login. This is it. Okay, hey, you're logging. All right, cool. And then I want you now to create is this object, which is going to define as a user one, and using the new keyword to automate this process, or this is a sophisticated way to create objects here by just saying user.creator. This is the solution too that we are manually creating is our object reference. Okay, so far so good. In fact, let me actually store this in a particular property here. That's right. Okay. So once we do this, and then when we want to actually access to the login, okay, hey, you're logging. Good, good, awesome. But what if we want to actually create now a new user, pay user, to cover a business use case? And how can we now create is the reference from this as a way to access to this property? So, well, we'll actually start with this way by saying, hey, this is the function pay new user. What we here need to receive is the name, the scores, as well as the I don't think we actually didn't create that grade because we didn't pass name and score, which is that's something that is going to buy or bought. Okay, this is something that is going to buy or bought. So we prefer to define is the name Alice, okay, followed by score 5, and now this is it. What you want to call is now the name, user 1, the name. There you got it. Hey, you're logging and Alice. Good. So now if we want to create this a new object to cover a new use case as a way to extend the functionality of our application, we do this. We say, hey, let's going to define now this function called pay new user, where here we're gonna receive is the name as well as the score and some new property for this object, which is a balance. All right, so this new object here, we can use the object of create for that, but this will only has a reference to that object. Okay, how can we actually now update the reference for this? So by creating this, or by in this particular case, creating is our user. Let's say new paid user. Okay, where we want is to now is create this user. We say user creator. What's the name of the function here? Is the user creator. Okay, we're gonna pass is the name as well as the score. Okay, so now this new pay user has a reference to the user functionalities. Okay, to those base functionality. How can we now update is our local reference? For that, there is an property called object.set prototype of, that is saying, hey, let's going to forget about this proto, and now I want you to update to that. So with using this object.set prototype, we are saying is that forget the new pay users here, and now I want you to bind to my local functionality, and I want my local functionality, or for the pay new user, actually points to that. let's get into this. Let's get into this. Let me define now this object called user new functionality, or user paid functions. Okay, you're gonna have here an object that says increment balance, which is a function that it say, hey, I want now to, well, access to the balance property and increment that. Okay, so far so good. So this is what we can do here. Okay, so but we also need to remember that at the end of the day, we would like to access to the proto. We would like to make this object to access to the other properties and methods, especially for the user functions. So we're gonna do that, but first I'm going to define now the new paid user.balance property, okay, and attach that balance, and then we're gonna now return our object, which is new pay users. All right, we just tell JavaScript, hey, this object prototype, okay, I want you to now point to the relevant functions, user pay functions, but also I want now to indicate somehow to the user pay functions that this object can have access to the other property methods. So to do that, we can do this right below here and say object.set prototype of the user pay function here is that forget about your proto, and I want you to now point to the user's functions. All right, and now once we create this, which is, let's going to create now a user or paid user one, and say, hey, I want you to now run this paid new user, and it's going to pass is the name of Bob and 5 as a score, and the balance 10. Okay, and I want now to have access to the pay new user's current function, which is increment balance, increment balance. Okay, and I also want to have access to the new user dot login, which are functionality from this base class. When we hit this, it's a pay new users increment balance. It's not a function. Increment balance here. Increment balance here. Oh, no. Wait a single moment. Makes sense. It's because here we are actually linking to these current properties, but we need to find a way to now link the user paid function to the user functions, which is here, to the user function. But increment balance. Okay, This is now do something here. New pay user, okay, to user paid functions. So far so good. Oh no, we are actually calling that properly. And we're saying user pay functions to point to the user functions. Yep. I actually have this code here. And the pay new user here. Object set the prototype the new pay users to the pay users to the current functionality, and you return that object exactly. New pay users, okay. Pay user 1 is calling this pay new user, and pay new users that's quite interesting. It say, hey, I don't have that property that you mentioned. That's quite interesting. That's very, very interesting. That you didn't get it. What about refresh this? It was something that I didn't define properly. User creator, object of set prototype, the new pay user with the pay user functions that we define here. That's right. And then new pay user balance and that kind of thing. Okay. Let's open up a new tab here to actually check our code here. User this. So this is actually going to work as expected, no problem. But when we want to create now this particular inheritance or have access to this, we define this like so, right? We say, hey, this is the user pay function, which is an object. Increment balance is the name of that, which is a function that I want you to have access to the balance property. And then here, by defining as a function pay new user, okay, where I calling is the user creator function, pass the proper parameters or arguments to these new functions. What we're gonna receive is the user creator that has a reference to there, but in our case I want you to now update the reference here. New pay user, exactly, new pay user, I want you to point to the user pay functions. So far so good. a new pay user, but it seems like the problem is here. And then after we run that function, you say, hey, object of set prototype of user pay functions to the user functions. To the user functions. Increment balance. Okay. And then he say, hey, I don't recognize. Oh my god, I'm not dumb. Human error. There you got it. Hey, you log in. Human error, as usual. But as you can see here, this is the way of how you can now access the property methods based on the previous work you have done to cover a use cases. That's fantastic. That's brilliant. That's actually save you a lot of time as a developer. Totally. It's like, oh my god. It's like, oh my god. Okay. This saves you a lot of time as a developer. Because not only that, is that it allows you to know the code that you're reading is maintainable, is reusable, and also you can extend that easily. It's actually following is the solid principle. This solid principle, okay, which is now you can make that particular bundle have a one single responsibility to work with this data and this functionality. Okay, single responsibility is open to extension close to modifications. Please follow this. The list substitution. This is something that is quite not understood by a lot of developers, and I am not one of those developers. Functions that use pointers or reference to base class must be able to use or derive class without knowing it. Design by contract. Design by contract, also known as contract programming. Programming by contract. And design by contract is an approach for designing software. So functions that use pointers or reference to base classes must be able to use objects of derived classes without knowing it. In other words, that how you can have access to other property and methods, that object must have access to all of those properties and methods. The list substitution principle. Oh, all hail. List-Gov is a particular definition of subtyping relationship, something that we're talking about here, called strong behavioral subtyping, that was initially introduced by Barbara List-Gov in a 1986 conference keynote address titled Data Structures and Hierarchies. It is based on the concept of substitutability. In principle, in object-oriented programming, remember that after all is data and it is relevant functionality. That's the whole reason why we want to do this. Starting that an object, such as a class, may be replaced by sub-object, such as a class that extends the first class without breaking the program. Totally. It is semantic rather than merely syntactic relationship because it intends to guarantee semantic interoperability. Semantic interoperability. Hey, this new class that I'm creating here, okay, a principle in object programming stating that an object may be replaced by a sub-object without breaking the program. So as an object may be replaced by a sub-object without breaking the programs. In other words, is that the reference or the relationship that this new subclass can have to replace these objects is the same here. So by updating is the reference. By updating is the reference from this new object that hold the same from this base class. You can now get rid of that class and everything will work as expected. That's quite interesting here, because it intends to guarantee semantic interoperability. In other words, this new class that we got here, it will guarantee this semantic interoperability. It means that you can now replace this object with the base parent once you update in their proper reference. And Janet Wynn. What? First time I hear you about it. What? Holy hell. Oh my God. She was corporate vice president of Microsoft Research, with oversight of its core research laboratory around the world and Microsoft Research Connections. Prior to 2013, she was a president professor of computer science at Carnegie Mellon University, Pittsburgh, Pennsylvania, United States. She also served as an assistant director for computer and information science and engineering at NSF, National Science Foundation. She was appointed to Columbia University Executive Vice President for Research in 2021. Electrical engineering and computer science, of course. It's like, of course. At MIT in June 1979. God damn. Her advisors were Ronald Rivest and John Racer. In 1983, she earned her PhD in computer science at MIT under John Gunta. She is a 4th-degree black belt in Tansong Do. 4th degree. Okay. Career and research. With Barbara Liskov, she developed the Liskov substitution principle. Holy hell. After graduating from Stanford, Liskov returned to Mitre to work as research staff. Liskov substitution principle. She leads the programming methodology group at MIT with a current research focus in Byzantine fault tolerance. Oh my God. Imperfect information on whether a component has failed. The term takes its name at the allegory of Byzantine general problems. If a general attacks in coordination, the battle is won. If two generals falsely declare that they intend to attack but instead retreat, the battle is lost. the Byzantine general problems. And distributed computing. She was on the inaugural. Okay. That's quite interesting. Barbara Liskov and Janet Wynne. Holy moly. But again, all of this is because we were looking at the solid principle here, which is now mnemonic for 5 design principles. Design principles intended. Design principles. Why this is important, especially on the design? Because the designer carry huge amounts of responsibility, especially when they need to create whatever they need to. But again, this is 5 design principles intend to make opportunity designs more understandable, flexible, and maintainable. That's the whole point of this. Also, the solid principle applied to any object-oriented design, they can also form a core philosophy for methodologies such as agile development or adaptive software development, which is part of the reason here. Adaptive software development. Janet Wynne. Interesting. Janet Wynne. All right. First time in my life that I hear her. Yep. First time in my life that I hear that. How I learned code. What the hell is this? Oh, but it's in Spanish. Okay. What?
Are put forth before.
Okay.
For us as scientists, because machines still can't do them as well as humans.
Computing
But
is
that's, if you will, just the
of
base
abstraction.
case. I also like to talk about humans and machines together. In fact, networks of humans and machines together as an automaton. So think now, is this the most efficient way to solve the problem? And when I talk about efficiency, I talk about it.
Measures of good abstraction in CT. Efficiency. Okay. Janet M. Wynne. What the hell is this? Dell HMC. Video produced by the Florida Institute of Human Machine Cognition. Ah, okay. Alright. Okay. That's interesting. Yep. Lectures. Okay. Interesting.
For us as scientists, because machines, they're just going to give this as a solve. So, or should they?
In the world by the middle 21st century.
And of course, it's an incestuous vision in that computing and computers will enable the spread of computational thinking. Now, This vision has grave implications with respect to the research in any discipline that we conduct, as well as educational implications, which I will talk about a little bit,
14
especially
years,
with respect
god
to
damn.
K-12. And so if you are interested in
Holy
this talk that I'm
moly.
giving today, I wrote a very short article, it's only 3 pages long, that appeared in CACM a few years ago. And it really captures a lot of what I'm going to say today. So, computing. Let's first talk about computing. Computing is what I like to call the automation of abstractions. This is quite abstract, and I will try to explain what I mean by
The automation of abstraction. Computing. The automation of oh my god, the computing is the automation of abstraction. Alright, for example, automation of abstractions. An abstraction can be what'll be our best way to don't worry about how much do I need to eat, how much calorie, how much protein, vitamins, that kind of thing. While enjoying the food. So what'll be is this automation, this system that I want to do for an end goal. And how can I automate that process? It is pretty fucked up because at the end of the day, this is the thing that I have done, especially with my nutrition. I just automate that abstraction. That abstraction, which is the idea or the goal that I have in mind, which is keep my body in a fit way possible, as much as possible, that allow me to now live as much functional as much as possible at my 50s, 60s, 80s, 90, 100, that kind of thing. So, yep. So that's the idea here. Okay? That the abstraction here. So how you can now make that idea a reality and how you can now automate that idea. God damn it. Jesus fucking Christ. Oh my God.
About computing in terms of these two A's, automation and abstractions. And it really is this feedback loop that one has when you're abstracting from some physical world phenomenon, creating a mathematical model of this physical world phenomenon, and then analyzing the abstraction, doing sorts of manipulations of this abstraction, and in fact automating the abstraction that then tells us more about the physical world phenomenon that we're actually modeling. When I talk about automation, and this is a whole other talk I could give, so I'm just going to give this as a side note.
We use some mathematical models. And mathematics is something that you can learn from, which is learn. And models is this particular construct. Oh, okay. That's quite interesting. Oh my God. Oh, nigga. I define as a mathematical model for myself as a way to consume calories and proteins and that kind of thing. I define that. Jesus.
When I talk about automation, I'm very careful to include that the automaton can be a human or it could be a machine. After all, humans compute. We may not be as fast as machines, but in fact there are some ways that humans are much, much better computers than machines. In other words, there's still some tasks that humans can solve better than machines. Vision is one example. Speech, natural language processing. A lot of the challenges of artificial intelligence are put forth for us as scientists because machines still can't do them as well as humans. But that's, if you will, just the base case. I also like to talk about humans and machines together. In fact, networks of humans and machines together as an automaton. So think now that you can bring together the intelligence of a human with the intelligence of a machine, networks of them, that itself is collective intelligence.
Exactly.
That could be an automaton in my world of automation. So that's
Yeah, damn.
quite a powerful notion,
Mm-hmm.
very unusual, and I'm going to save that thought because I'm going to come back to it at the end of my talk. As I said, that's just part of the picture with respect to computing or computer science. But that's really not what I'm going to talk about for the most of my talk. I'm really going to focus on the abstraction part of computing. Computational thinking is really, that allows us to focus at each layer only on the properties or the behaviors of interest. And then we build these complex systems by layering or other means of composition. So when we talk about abstraction, it's not just the abstraction or the particular model. It's the layers and also the relationships between the layers. And because we usually define these abstract models in very precise terms, mathematical terms, we are able to define the relationships between these layers also precisely. Is this the most efficient way to solve the problem? And when I talk about efficiency, I talk about it in terms of space and time. Is this the fastest way to get from here to there? Is this a procedure which is going to require the least amount of space? So that's space and time. And I think what's most interesting right now is there's a lot of interest in what I would call the third dimension of analyzing the complexity of the kinds of abstractions we invent. And that has to do with energy. There's so much interest now, societally, from the administration, on energy. And I think computing as a discipline needs to revisit a lot of the abstractions we've invented already in terms of this third dimension. So for those of you who are researchers in computer science, I advocate that we're going to have to throw out all our algorithms textbooks and rewrite them all in terms of these three dimensions now. The other measure of goodness for the abstractions that computer scientists like to invent is correctness. After all, when you're writing a program or you're building a system, you want it to do the right thing. And so we always ask not only how fast does this, say, algorithm perform, but does it do the right thing? And what does it do the right thing mean? We usually ask, for instance, does a program compute the right answer? And that alone, answering that question alone opens up a lot of research questions. But we also want it to do something useful. So it's not enough that it does the right thing. We actually want the answer to be spit out eventually. And that's the question of, does the program eventually produce an answer? And there are complexity results that show that this isn't always an easy question to answer. And then, of course, there's the other illities, if you will, when we look at a particular abstraction and judge whether it's good or not. Simplicity and elegance, as we have for mathematics, usability, modifiability, maintainability, cost, and so on. Now, if you look at this list, you'll say, well, that's no different from good engineering. And so, in fact, computational thinking or computing in very much draws on mathematical
question. Where the word engineering came from, bro? Where the word engineering came from, bro? Jesus. Etymology of engineering. God damn. Okay. Middle 14th century. Ingenieur. What is this? Latin? French? Ingenieur. Construction of military engines. For military purpose, bro. Exactly. From Old French, ingenieur. Engineer, architect, make of war engine. The maker of war engines. Schemer. 12th century from late Latin, ingeniare. Engine, general sense of inventor or designer. Is recorded from early 15th century, from late Latin ingeniare, see engine. Circa 13th century, mechanical device, especially one used in war. Manner of construction, also skill, craft, inability or ability, deceitfulness, trickery. Interesting. It's a skill, is a craft. Engine, from Old French engine, skill with cleverness. Also trick, deceit, stratagem, war machine. And it is interesting because this word is deeply rooted in our nature of war, in our nature of violence. In our nature of war and violence. So in 15th century, general sense of inventor, designer, is recorded for early 15th century. Civil sense, in reference to public work, is recorded from century 16, but not the common meaning of the word until 19th century. Hence, lingering distinction as civil engineering, meaning locomotive driver, is first attest 1832. American English, a maker of the engine. In ancient Greek was mechanopois. But this is engine as a noun, okay? An engine as engineer as a noun, and engineering as an action. Act as an engineer, from engineer. Figurative senses of arrange, constructive, guide or manage via ingenuity or tact. Is a test from 1864, originally political context, related engineering. Middle English has a verb engine, contrive and construct. Late 14th century also seduce, trick and deceive. And seen in 13th century and put to torture. Oh my God. Work done by engineers. But this is interesting because the word engineer, the noun engineer, according to the myth, exactly. So the word engineer, from Old French ingénieur, is engineer, architect, maker of war engines, schemer. That's exactly what a lot of us are. We are schemers. We're schemers. We are builders. We are architects, maker of war engines. That's quite interesting, bro. That's very, very interesting. General sense of inventors and design. Why this is important? Because especially you can call yourself of an engineering, but you need to know is where this word came from as a way to similar as the profession. All right, that come from 14th century in French, from Old French, profession. I think I did it. I think I mentioned that, right? That means that the act of is vows taking upon entering a religion, which is commitment, okay, to one thing. And here the engineering is a schemer, is someone that now is the maker of war engines. Okay. The architect. But as a way to be an architect or an engineer or a schemer, you need to align to the nature. Because no matter how much no matter how much you want to plan or scheme or create or architect, it's the nature that actually tells you what it is, what truly is. And I really love about this interlude.
However, we in computing can build virtual worlds, worlds that are unconstrained by physical reality. And so when you how to use Word or Excel or PowerPoint, computational thinking is not that. And I distinguish between computational thinking and computer programming, because computing is a lot more than computer programming.
Exactly, complexity, algorithm, data. In complexity, algorithm, data structure, abstract machines, architecture, linguistic syntax, semantic, grammar, computer literacy, how to use Word and Excel or even Google, computer programming beyond JavaScript programming 101. Exactly. It's like, okay, how you can now scale to that, how you can now work with data, a large collection of data. I get it. Potpourri of concept. Potpourri. Oh, you call that potpourri? You call that, and potpourri is a food? Oh my god. I don't know anything, bro. Potpourri is a food, bro? No, it's a flower. What the hell is potpourri, bro? Oh, cajón desastre. Potpourri. Oh my god. No, it's okay. It's Did you know what potpourri means for? What? Anyway, she mentions the potpourri, and after all, the idea of today's video is to
Particular computational me approach my problem in a new way. Answer is right. It was the shotgun algorithm that expedited the sequencing of the human genome. That all of a sudden caused a lot of interest by the biologists, by the whole medical and biology community, say, hey, there is something to computer science, to algorithms, more than just processing power. So that's the point I'm trying to make, that computing is more than just about devices and horsepower and supercomputers. And this particular algorithm was what I think the tipping point for when biology and computer science started to come together. And since then, there have been many, many examples of different kinds of computational methods, different kinds of computational models, different kinds of computational languages, different kinds of computational approaches for understanding biology. I've just listed a few. A lot of this is states, those are the circles, and their transitions between the states. Those are the state transitions, the lines, the arrows. And what makes this a finite state machine is there are a finite number of circles, finite number of states. Okay, so that's one input. And it actually is critical for us to push a button and get that black box answer. What they really do is statistical machine learning. Okay. Another example is that there are departments of statistics now at universities, for instance, Purdue, which has an excellent statistics department, who are hiring computer scientists because they see their future as in this combination of statistics and computing in terms because of this particular technique. In medicine, it's been used for discovering and inventing the. They're tracking your purchases, and the coupon that you get out after your receipt it's using that kind of analysis of large amounts of data. Recommendation systems and reputation systems like Netflix. When you go to Travelocity to find out, you come in the middle and you have that interface at MIT would very much like. All of a sudden, this new interest, or a completely new interest in revisiting economic models and theories in terms of computing models and vice versa. So for instance, we are very much using game theoretic models in looking at lots of problems in computer science every year from grade to grade on the concepts they've learned already. My analogy is mathematics. We know in kindergarten we can teach numbers. By 7th grade we can teach algebra. By 12th grade we can teach calculus in mathematics. We've somehow figured this out, the math profession, but more than the math profession, the people who understand childhood development and how children's brains learn over time. What abstractions can they learn when they're 5 years old versus what abstractions can they learn when they're 18 years old? And we've somehow figured this all out. But we don't have that kind of analogy in computer science. And so this is my challenge to the community. First we have to figure out what those concepts are, and then we have to. Alarms me what our kids don't. Broadly for the nation with respect to STEM education is really, right now STEM stands for science, technology, engineering, and mathematics. And they've been very engaged with at NSF, getting my coffee in the morning. Okay, so this is a true story. So first I get, what would you say when you look at that? It's inefficient. And in computer science, the way we would, oh, by the way, it's even worse with two people, right? And this is a real frustration because, I'm standing there and you want your caffeine in the morning and there's someone in the way, like getting coffee or soda. It's like, get out of my way. But you have to be patient. Anyway, but so what do I think? I think such that I can create a pipeline. This is like, overdoing it. Oh, and then I think.
Oh my god, man. Okay. Anyway, I didn't get a lot of time to actually look at this, because I recognize that something important from all of this talk, okay, and that is the ability to now automate abstraction. And I love, oh my god, the ability to automate abstractions is yeah, the ability to automate abstraction for a goal is something that I have done The ability to automate abstraction for a goal is something that I have done with my nutrition. Anyway. It's because now. Okay. Okay. We were talking about is all of this solid principle as a way to describe what's going on, what's happening, and how you can, I think this is something that anytime you learn something, okay, no matter which thing it is, try to see how you can benefit from that as a way to apply in your daily life, okay, to solve a particular problem that you want, whatever it be. In my particular case, I did that. I now automate an abstraction, which is I want to look good and feel good by eating. Okay, in my nutritional aspect, so I automate that abstraction, and the other is that I automate now the how can I look good. I automate that fitness abstractions. That's something interesting. That's something interesting. And something that now I'm automating here, okay, is the abstraction of learning about JavaScript and this intrinsic nature. And not only learning JavaScript, but also is learning with a particular approach, which is storytelling. And that is by abstracting this and automates that process. In this case, I'm abstracting is the learning process, at least for one field, right? The learning process of the professional field. Okay, so by abstracting that process, it automates that, which is I'm dedicating time to this until I learn how do we get here. That makes a lot of sense here. And let me actually define this as it is. Okay, because we were looking now at the solid principle. This mnemonic acronym for 5 design principles intend to make object-oriented programming designs more understandable. And my God, yeah, it is. Because after all, most of the time we're going to read code, bro, or girl, if you like it or not. Flexible and maintainable. But again, this is something important. So this list of substitution, okay, and they create now this subtype requirement, let be a property provable about objects in C type of T. Okay, I don't know what is this one, but they say is this subtype requirements let, what in the F this mean? Exactly. A shorthand for the cumulative normal density. What? Cumulative normal density. Función de Euler. Oh, fuck off, man. What the hell is a función de Euler? What is this? The non-standard notation comes from Gauss. Ah, we get it. The Dutch, German. No, but this is different. Why is it useful of this, bro? What is the useful shit of this? I have to define like a growth rate? Totion's number, but what the hell is that Totion? In number theory. Oh my god. Meaning. Oh, Totion. A quantity of number less than and sharing no common factors with a given number. Okay, so they don't have any relationship. Is a number, okay, is a quantity of number that they don't have any relationship. So let this number, let the be a property provable about the object that don't have any relationship. Then G should be true for objects G of type S, where S is a subtype of T. So Liskov notation of a behavioral subtypes define a notion of substitutability for objects. Okay. Liskov notation of behavioral subtypes define a notion of substitutability for objects. That is S is a subtype of T, so I'm extending is all of the property of U, but I have my own properties, okay? Then the object of the T in a program may be replaced with object of type S without altering any of the desirable property of the program. Exactly. This Liskov substitution is that a subclass from a base class, okay, maybe replace this subtype class, maybe replace that, and when do that, it won't affect the program's logic. It won't affect, it won't altering of any of the desired property of the program, aka the correctness. That's interesting because, for example, here, okay, since for some reason now I want this to replace this object with the base class, okay, I can do that by not necessarily calling the user creator and in fact create my own object for that and not losing all the properties and inheritance for that. This subtype of these objects can be replaced the object with all, well, guarantee the correctness of the application. Makes a lot of sense. List of substitution. Okay. As a way to, for example, be less verbose or now guarantee interoperability here. Not only guarantee interoperability, guarantee interoperability here. Interface segregation principle. Clients should not be forced to depend upon interface that they not use. Interface segregations. Hey, I shouldn't be forced to depend on an interface that I'm not using, which means make it optional. Okay. In ATM transaction example, and in an article also written by Robert C. Martin, specifically about the ESP, this example discussed the user interface of an ATM which handles all requests, such as deposit requests or a withdrawal request, and how this interface needs to be segregated into individual and more specific interface. While consulting for Xerox. Making modification become more and more difficult so that even the smallest change will take a redeployment cycle of an hour, which made development nearly impossible. Oh my god. The design problem was the single job class was used by almost all of the tasks. Whenever a print job of stamping job needs to be performed, a call was made to a job class. This results in a fat class with multitudes of methods specific to a variety of different clients. Because of its design, a sample job will know about all the methods of the print job, even those that were not used for them. Exactly. The solution suggested by Martin utilized what is today called the interface segregation principle. Hey, the client should not be forced to use functionality that it doesn't require to. Instead of having one large job class, a sample job interface or a print job interface was created that will be used by sample or print classes respectively, calling method to the job class. Therefore, one interface was created for each job type which was implemented by job class. Okay, as a way to now segregate, interface segregate principles. When you're creating this subclass, it has these particular interfaces. Okay. especially on microservices. And then you got dependency inversion. In object-oriented design, the dependency inversion principle is a specific methodology for loosely coupling software models. High-level models should not import anything from low-level models. High-level models should not import anything from low-level models. Abstraction should not depend on details. Details, concrete implementation should depend on abstractions. Dependency inversion principle. Okay, so this abstraction should not depend on detail. By dictating that both high-level and low-level objects must depend on the same abstraction, this design principle inverts the way some people may think about object-oriented programming. The idea behind points A and point B to this principle is that when designing the interactions between a high-level model and a low-level one, the interaction should be thought as an abstract interaction between them. This is not only has implication of the design of the high-level model, but also on the low-level one. The low-level one should be designed with the interaction in mind, and it may be necessary to change its usage interface. In many cases, thinking about the interaction in itself as an abstract concept allowed the decoupling of the component to be reduced without introducing additional coding pattern. Allowing the lighter and less implementation depending interaction schema. When the discovery abstraction in traditional layer patterns. Dependency inversion, exactly. In this composition, higher level dependent. With the addition of abstract layer, both high and lower level reduce the traditional dependencies from top to bottom. Nevertheless, the inversion concept does not mean that lower level layers depend on higher levels directly. Both layers should depend on abstractions, not on implementations. Okay. Dependency inversion principle. Both of them must depend is on abstractions. That's quite interesting. Okay. Anyway. So the thing here is that we're looking now how subclassing works in real time. And, well, one of the things here with this set prototype of is to me like quite challenging, because at the end of the day is that we're not setting is the prototype, we're setting is the dunder prototype, where now in the spec they define that as prototype double square brackets prototype double square bracket, and that's actually doesn't make sense. It's like it's more confusing, but this is the way of how you can now, by creating a new subclass, in other words, by creating now a use case to cover here our game, the user paying user, we can now have much more sense of how can we now inherit, or for a better term is access to the current functionality from this create new users or this new base class and update the reference from that functionality to the upper class. So that's something interesting. That's very, very lovely here. So as long as this follows this solid principle, okay, hey, this subclass must have one single responsibility. They must be open to extension, close to modifications. They must follow is the LISOC substitution, which means that if I derive a subtype, if I create a subtype of this class, now I can replace, or I may replace that here, okay? I may replace that here. I may replace that subclass with the base class to guarantee operability. In other words, we're not breaking the code. We'll guarantee the correctness of the code. And the other is interface segregation, which is you're going to create now subclasses or interfaces for particularly subclasses, okay? And the other is the dependency inversion. In other words, as a way to interact with lower level layers, create an interface or create an abstraction here to interact with them. So okay, this is something great, something good, okay, on how we can now define objects and how can we do subclassing here in JavaScript using now the object of create. So we're manually creating is all of this reference, okay? So this is called the sophisticated way, how you can subclass them with factory functions. So now, in today's video, we're gonna take a look now at how can we do the subclassing but with the new keyword. Here we go. All right. So in our particular case, let me refresh this, and that is create function. It's gonna create now a function using now the new keyword by saying, hey, this is the user creator function that is going to receive is the name and the score, because we are building is a game. All right, and now we make use of this keyword, which is a property that has the function execution context, okay, that when JavaScript runs this function, it will say, okay, the value of this will be whatever is on the left side. This is one rule of this value under the function execution, because when we are now in other contexts like arrow execution context, now the value of this change, especially if you're running with the new keyword. But right now, let's gonna do this. So all functions have access to this as a way to referencing the proper data. Okay. So in our case is name, followed by the name here, and score, followed by the name score. So far so good, because now we are going now to create is under the function object. If you remember, functions are a special type of objects where you can call them and you can define, you can add properties to that under the prototype, which is the object portion of the function object. Okay, so in our case, under the user creator.prototype, okay, I want you to add this function like increment, okay, function here where I want you to now here make the this dot score score score. So increment that, that's what you're gonna do, increment that. And the other is the user created of another function prototype dot login, what I want to define is the function here, right? And here I say, hey, I just want this to console log here, hey, you're logging, hey, you are logging. Okay, now that I define the data and the functionality, okay, which is great, that's exactly what object-oriented programming is all about, is how can I make this data and the functionality bundled together. How can I make relevant data and its functionality bundled together? So now I want you to create these objects. The way to do that using the function constructor is by defining a new const, hey JavaScript, reserve space in memory for this new user that is name. In this case, let's say Alice, and the score is 5. And then I want now to do this. Run the function of increment. Okay. I want to now know what is the value of my score. Okay. And also I want now is to run the login method. And as you can see, there you got it. There you got it. So because we need to actually is print a console log that value. Okay, user like user1 dot score. You got it, a 6. So we actually is now working with this object. So we've successfully created this object. That's beautiful. That's powerful. That's interesting. So now here, let's go now to create is the subclass. Pretty much we're going to follow the same pattern. That's going to create as our function. There's a couple of stuff here that's going on, especially here when we're using the new keyword. Because when we are creating or when we are running this function, we're telling to this function to behave in a particular way, which is the value of this will be an empty object, okay? And let's go into now adding all of the property to this as the current argument. Update the proto reference, okay, to the object, to update this object's proto reference to the function constructor prototype portion of the user creator, where we're going to put all of our functionality here, and then return the object here, which is the name and score. So if you don't trust what if you don't trust what if you think I'm losing my mind, well, let's gonna check that out. User creator, let's say, hey Bob, call Bob, and then we're gonna call this 5, right? Exactly. It didn't do anything because it is a function. So we just call this function, but we're not returning anything. So we call with new keyword, now it's actually doing as expected. It set now the prototype to point to that, which is something that it does for us, okay, to the increment and login, and now we can run those functions. That actually is what you're going to see a lot in professional code bases, okay. So when it comes to actually is creating a subclass of this, okay, we follow the approach, the following approach, the same approach by that. So we replicate that by saying, hey, there will be a function called pay user. Pay user. Well, now we're going to have is the name, okay, as well as the score and balance, okay. And here we want us to call this new function. But the thing is that if we say this const user, if we say this new user creator, what will happen is that the object that we have is pointing, okay. What will happen is the object that we pass, for example, with the name and the score here, the object that we're gonna have here is pointing to the proper properties, you know. So wouldn't be a way to actually do this, right? Hey, I want you to now set the value of this, okay, to be to this new object, okay, and and not only that, I want you to now update my prototype here by adding the proper properties, okay. And so, for example, by adding my new properties here, and from that prototype, from this new functionality, I want us to make the reference to that, not on this object. So how can we do this thing? So because now this particular way of how you can is, and that might be one of the peculiar things here of all of this, okay, is that by running this function here, okay, we are going to now, by calling this function here, what happened is that we want is to, so when you run this, we don't want a new object created for us. In fact, we want is to update the value of this somehow, okay. We want you to update the value of this. We want to update the value of this pay user function with the relevant data that we get here. How can we do that? Glad you asked. So because that, we're going to run now our function, and in fact we're going to do is this user.creator.call. we're going to call our function, and we're going to pass is this reference from this pay user, followed by the arguments here, which is the name and score. So we are calling is this function, and we're passing is the value of this. So when this function creates its own function execution context, and now put all of this reference to this value, we are now wants to get this value updated from this function. That's one of the most finicky, intricate mechanisms, especially of doing subclassing here. Especially of doing subclassing here as a way to say, hey, let's say PM came here and say, hey, we need to develop this new particular feature. Can you do that? You know? Can you do that for us? Yes? Good. All right. Great. Can you do that? Good. All right. Great. User creator that call this. So once you run this function and you pass the relevant this to the inner to that user creator, when the user creator runs, because we are updating is the reference of this inside of the user creator, when this function is over, now it updates the value of this for our paid users. So we effectively are creating is a side effect here. And that's one of the most, now you can see here in real life how we are using is this method from the function, okay, function object call, or it can be applied, but if you pass apply, this parameter must be an array, okay. And once that you get this value updated, okay, now it is time to set the prototype for this object. How can we do that? First, we need to define is the balance here as balance. So once we run this function, okay, with the new keyword, I want you to now say paid user dot prototype, okay, to now link this prototype from this paid user to the functions or to the prototype from our class function. You know what I mean? So we're now updating is the prototype references have access to the base class. In other words, it's saying user one dot is the user creator dot prototype. So here we're saying, hey, I want you to now, this paid user can have access to the base class and also have its own properties. For example, prototype, which is a function here. We can say like this, increment balance. All right, that'll be is the increment. Exactly. That'll be this increment balance here as the function. Okay, where I just want is to this function do is this dot balance, like that, increment balance. And then right after that, I want now is to finally create that new object here, where you say, hey, this is the new user. I'm going to call this new user, or paid user one to have more meaning. And then you say, hey, I want you to run this function with this new keyword, where now you're going to receive is the Alice and 5 and 11. I want now you to run this increment balance. All right. I also want to now run is the login function, and then print the pay user balance property. As you can see, it actually do what it's supposed to, and that's something beautiful. So that's why interesting in the way of how now using the new class keyword, how can we have access to this property here? Okay, it makes a lot of sense, especially if you want to create now, especially if you want to extend functionalities, okay? As a way to understand what's going on behind the scenes. Because with this particular approach, okay, now that we look at this, now we know in real life, at first hand, we got a test of what this is doing. So now we can move on to the subclassing with class as it is. Exactly, creating a subclass with a constructor. Like this one. Okay. So here is the code from exactly creating a new object here. So this is our code. Okay. And I'm creating a subclass with a constructor, which is something that we did here. Wait, what? I know, because it's this. With a constructor function. Oops. All right. And then
so now let's okay, so this we exit out as execution add to make it yeah. And
so here we're going to see is assigning properties to using a call method in a constructor.
okay, let's get creating page user one. Here that we want to add the properties to. Here, it was created all out to the this one layer out. But JavaScript doesn't pass it in as a label this. It says pass in this. When I'm in page user creator, what the hell is this? Oh, it's this object here. And it literally grabs that object and passes in a reference to it, you know, with the proto and like, that's what's being passed in. So we end up just with this inside of user creator referring to the object out here. So now, Seth, we're inside a user creator. We have a nice this that refers to an object. By the way, note, side effect. This is a side effect from within user creator. We're probably not going to return anything out because we're changing stuff one layer out already. And so Seth, talk me through the assignment that now happens inside of user created. We've got to add this. It refers to the object created and paid user created with the help of new. Talk me through the assignment. Oh, sorry, before assignment, forgive me, man. We've got to do our, no, my fault. We've got to do our argument. So we've got to add this in local memory. Yeah. Let's call this a bit, I'll be a bit cautious to call it that because it's not actually, we are explicitly, it feels like the let's call this and like our arrow function, but let's call this actually is stored on a property of a function as a let's call this. Here we are explicitly saying it's the object one there. I see where you're going with the let's call this. That's not an unreasonable term to call it. Yeah, okay. I can take that. Yeah, that's fine. That's actually not an unreasonable term to call it. So this dot name, but it refers to the object one layer out, saying it's the object one layer out. I see a let's call this. Here we are explicitly saying it's the object one layer out. I see where you're going with the let's call this. That's not an unreasonable term. Here we are a let's call this. Here we are explicitly, this actually is stored on a property of a function as a let's call this. Here we are explicitly.
So this is now exactly. It's using a call method.
Let's get creating paid user one. Here we go.
Using a call method in a constructor. Okay, anyway. It's using a call method in a constructor. What happened when we want to update the value of this in our own the value of this in our own new object called pay user. And on our new object function or new function constructor called pay user. Okay. Pay user. Yep. So this diagram explains what happened when we want to update the value of this in our own new function constructor called pay user. Yeah, that makes sense. And how by calling the user creator function with the call method. We are creating a side effect to update our own pay user with the data from the user creator through this keyword. keyword bind. Holy moly.
So now, Seth, we're inside a user creator. We have an unreasonable term to call it. We're referring to an paid user creator. So actually, let's put this in here to make it really clear. This user one script. And especially if you use things like React, you're going to see on the final slide, this is the model behind React. There isn't really much more.
This is the model behind React. Is that when these functions change, so when you run this particular function here, okay, I want you to now call this.
This is the model behind React, this notion of having access to functionality is not directly there. React. There isn't really much more. This is the model behind React, this notion of having access to functionality is not directly there. And React. There isn't really much more. This is the model behind.
In here is now exactly assigning property to instance, assigning this diagram illustrate this diagram illustrate how data is passed to this keyword. This diagram illustrates how data is passed to this keyword. This diagram illustrates how data is passed to this keyword from the user creator to paid user creator exactly to the pay user creator for that. As a side effect. This is in fact how React works behind the scenes. This is in fact how React works behind the scenes. As a way to extend functionality, from these new functions.
Behind React, this notion of having access to functionality is not directly there.
Exactly. This notion of how you can have access. Oh my god, especially with the class keyword. This notion of how you can have access to functions that are not there.
As solution 4 is going to implement it the way React does. Didn't used to. React used to.
Exactly. And as solution 4, we are going to implement how React actually does that. It start with this. Exactly. Start with this approach. Exactly. But it started with this approach.
To implement it, if you remember, in the previous versions, before ES6 version, pretty much this way. ES6 version implements it this way. Implements it solution 4 way.
But it started with this. But it started with this approach. Before ES6.
In React. Okay, so it's got this bond up to, there it is, up to this object, the prototype object on page user creator, because of the new keyword help that ensure that the auto-created object got a bond to the function store on that function's prototype object. Let's do our checks, people. Let's do our checks. Do we have everything that we need? Do we have both our functions that are specific to a paid user type and our function that is specific, not specific, but available to all users? Let's do our check. Raise your hand if you want to do the lookup check. A collection of functions, and then those collection of functions have access to another collection. Well, let's see if it does have access. Let's do paid user. So this was a success. Let's do paid user 1.say name. Okay, David, take it away again.
Yep, page user 1 in global memory.
Perfect.
Checks for say name, it doesn't find it.
Yeah.
Follows its proto.
Oh, give me a second. I'm just going to change color so we'll use orange. So yeah, doesn't find it. Follows the proto up to
Page user
follows the
creator's prototype.
follows the prototype up to the prototype change to the portion, in this case this, to the pay user creator function, to the prototype portion, or to the prototype of the function constructor user creator. Doesn't find it, doesn't panic. Now it look up for the proto that has a reference to the prototype function constructor user creator.
There, nothing. So then it goes through its proto up to user creator, checks its proto for say name.
Oh, not proto, checks it's a prototype object.
Prototype object.
Does it find say name?
Yes, it does.
It does.
Boom.
We have access to functions that are specific to a paid user 1, a paid user 2, a paid user 100, and we have access to functions that are available to all users, but also still available through that chain up as to our specific paid user 1. Go ahead, Eric.
So we have lost reference to paid name, the parameter paid name.
Yeah. But that's not a problem. I called it paid. We have the parameter was just used to temporarily hold
Right.
Alyssa. Yeah. But that's not a problem.
Okay, because you want to. No, but it make it work.
I called it paid. We have the parameter was just used to temporarily hold
Right.
Alyssa before we stuck it on the object under the label name.
Right.
Yeah.
But it's not part of the global anymore.
No, well, it's definitely not available. No. Everything inside this execution context was deleted except for the user creator. That people.
All right.
So here we are with our final approach. This is our mega standard approach now to achieving object-oriented programming pretend style.
Oh, give me a second here. I'll give it to you. Pretend style.
relaxation state of your nervous system and your overall state of mind. It takes advantage of the fact that specific forms of breathing place us into a state of deep relaxation by slowing our heart rate down. It also takes advantage of the fact that we can control our perception, that is, which sensations we are focused on. And by doing so, we can shift our brain state from thinking, from stress, from planning, from anticipation of any kind, positive or negative, to one of pure sensation and deep relaxation. You'll want to do this protocol seated or lying down. So if you're not already seated or lying down, please do so now. You'll also want to close your eyes. So if your eyes aren't already closed, please close them now. Throughout this protocol, you'll want to breathe normally, unless instructed to do otherwise. One pattern of breath you'll be asked to do is to inhale deeply, ideally through your nose. But if you can't do it through your nose, inhale through your mouth. Try that now. And then exhale all of your air through your mouth. Let's do that again. Inhale deeply through your nose or your mouth. And then exhale completely. And as you do that, exhale through thinly pursed lips, as if through a small straw. Repeat that 2 more times. And understand that long extended exhales through the mouth slow our heart rate down and relax our nervous system. Then you can go back to breathing normally. Now, in your mind's eye, imagine yourself standing over yourself, looking down at your body, which is seated or lying down. And imagine holding a flashlight or a spotlight and directing that at your feet. Focus your attention on whatever it is that your feet happen to be in contact with. It could be socks, sandals, shoes, or merely the air. It doesn't matter. Focus your attention specifically on the bottoms of your feet and try and perceive whatever it is they are sensing. They could be tingling, could even be numb. It doesn't matter. Focus your attention specifically on the bottoms of your feet. Now imagine expanding that spotlight to include the tops of your feet, your shins, your calves. Expanding that spotlight further to include your thighs, your hamstrings, and up to your waist. Now, with your entire lower body illuminated, inside the beam of that spotlight, inhale deeply through your nose or through your mouth, and exhale completely through thinly pursed lips until your lungs are empty. Repeat that twice more. And each time, as you exhale, imagine your lower body sinking down about a centimeter into whatever surface they happen to be in contact with now. Now move the spotlight to your abdomen and focus your attention on whatever it is that your abdomen is sensing. As you inhale, your stomach should move out slightly, and as you muscles of your face. See if you can extend the duration of your exhales ever so slightly. And now, in your mind's eye, expand the spotlight downward to include your neck, your chest, your arms, your abdomen, your waist, your legs, and down to your feet. Imagine yourself looking down at your own body, illuminated inside of this spotlight. And in your mind's eye, deliberately dim that spotlight. Make the illumination less intense. Inhale deeply again through your nose or through your mouth. And exhale completely through thinly pursed lips. And as you do so, imagine your entire body sinking into the surface that it's in contact with. Now, while continuing to breathe normally, move your toes ever so slightly. You'll notice that you are in control of your nervous system. You direct your perceptions and your actions. Move your ankles and your knees just the slightest bit. Move your upper body from side to side, your head from side to side, or even nod just a slight. Move your head from side to side, or nod ever so slightly. And move your hands, lift your arms a tiny bit, and set them down again. And now slowly open your eyes, and as you do so, you'll notice that normally your nervous system is bombarded with sensory information, mostly visual information, which you have eliminated during this non-sleep deep rest protocol. You are able to control your perception by focusing on your sensations, and you can control which sensation you perceive by directing that attentional spotlight to whatever part or parts or entirety of your body that you like. This is the remarkable power of your brain. It can direct your actions and your perceptions, and it can do so in order to bring your actions and perceptions into heightened states of alertness, or, as you've done now during this non-sleep deep rest protocol, to bring your brain and body into a state of deep relaxation.
All right, let's get down to business. Here we are.
In a language, JavaScript, that is inherently a prototypal language, not an object-oriented one under the hood. But we are now able to really seemingly emulate approach. This is...
Oh. All right.
Is our mega standard approach now to achieving object-oriented programming pretend style in a language, JavaScript, that is inherently a prototypal language, not an object-oriented one under the hood. But we are now able to really seemingly emulate a object-oriented language within a prototypal environment. And this is it. Wow, okay. Beautiful. Left-hand side we've seen before. Note, I'm going to walk through it bit by bit now. This is our class version. We've got the function bit of the function-object combo, that when we run the function will create an object in user 1. Now it's got a subtitle, constructor. But it's still going to end up here. Our say, name, and increment now look as though they're just there. Oh, no, 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 no. Behind the scenes, how many no's is it? Behind the scenes, they are being stuck in the prototype object. No problem. So we're going to do that left-hand side first, and then the right-hand side here. We're going to lay out exactly how extends and super are working under the hood. We'll figure it out together. This is the last thing we do. Okay, here we go. Line 1. I can almost leave this up here because it's really the same, but I want us to actually build it out. So line 1, what are we doing? Let's have Chris. What does it say we're doing there, Chris? In line 1.
Declaring.
Yeah, it's already started.
We are declaring a class called user creator.
User creator, a class, which we know, I'm going to put in pink, pretend it's something special, but we know the truth. It's just a function object combo, as they always are. And the function bit, yes, now has a subtitle, constructor. But and the class is called what, Chris?
User creator.
User creator. It has a function, which when we put user creator parent, it's going to run that function. And that function now, when we wrap it, we give it a subtitle. What's the subtitle we give it, Elliot?
Constructor.
Constructor. But the function and the function object combo. But let's just call it constructor. There it is. So we run user creator with parent, we run the constructor bit of it. That is the function in the function object combo. Let's make sure we put the object bit in as well. There's the object bit, function plus object, and there it is. There it is. That's not the problem. And JavaScript immediately grabs the function, the constructor bit, sticks it on the function bit of the function object combo, and then it grabs, David, what just below?
Say name.
Say name, and it puts it on what?
The prototype
Prototype property
of the object function.
And there it is,
On
say
the
name.
object portion of the function.
So nothing has changed. To the very point that I could later add more functions directly, user creator.prototype, and put more functions in there. No problem. Okay, increment is also added. Increment is also added to our function object combo in its object portion under the prototype property. There it is. Okay, our setup is done. Elliot, let's get making our user 1 object. Take it away, man.
New constant is created user 1.
Yeah, initially uninitialized. And we're going to call what function?
Constructor.
Portion, yeah, the constructor portion of the class.
The construction
Just to be clear,
portion.
It's just a function. Yeah, in the function object combo. And we're passing what arguments?
Fill and
For we're going to create
A new branch execution context.
a new.
execution.
Oh, Michael, you made me proud. Seth, of course, absolutely. With the mutator, that is the new keyword that changes up how this execution context plays out. There it is. There it is. There's our execution context. New keyword starts doing stuff. Nick, you did this well last time. You mind doing it again? Help me out first with the parameter argument combos.
The parameter name gets the value fill, and the score gets the value.
Now, note people, just be clear. Running user creator runs the constructor portion. In other words, just as before, running user creator runs the function. That's all the class is. The function is now subtitled constructor. That's what it is. Okay, now new keyword starts doing its magic. Nick, help me out.
This object gets created with
Hold on. This is an empty, big old empty object. Yeah, with
a proto set to the prototype of the user creator.
Prototype of the user creator.
of the user creator object.
Exactly.
Function object.
Prototype of the portion
It is.
of user creator
Not particularly nicely done,
object.
but there we go. Yeah.
And then finally, this object gets set a property of name,
So now we take over. We're doing our bit here. Yeah.
of fill, and score of 4.
The object's stuck inside user creator. We don't want it in there.
It gets returned to user one.
It gets returned. The object with the label this, the designation this, gets returned out to user one. And there, folks, it is. With name, fill, score, or
It's more cleaner for the developer,
nice little cheeky link.
but behind the scenes, it's doing all of this manual.
Otherwise, we wouldn't have access to those functions. But
It's
you already-
automating that process of creating the reference, of access to the property.
All right. So, user 2, the same. It would also have a bond to that object. We won't play it out. Let's do our check. By the way, look how fast we are now. Look how fast we get through the stuff that was so demanding earlier. Remarkable. Good job, everybody. So, user 1 dot say name. Michael, do you mind doing my lookup journey here for JavaScript?
So user one's going to be looked upon in mobile memory,
Yeah, there it is.
and then say name is going to be try to be found, and
It's not there.
It's not there, so it's going to go to proto, and then crawl up, and then find say name under prototype.
Beautiful. We are now able to generate an object that does not have functions on it, and user 2 would be very similar, again with the specific data for user 2, but no functions copied on it, but they're still available. This will be it. It'd be pretty nice. But we want to produce a paid user that is just like a user, but a little bit more specific. It has some bonus functions, or so it has some bonus properties, but also some bonus functions that are going to work on those bonus properties. Perfect. Let's see if we can do it. Right hand side here, here we go. Here we go. I'm just putting this here to show everyone the right hand side. Who shall I call? David. Excellent. Help me out, David. We declare a class which is really a function object combo. Give me a second while I put it on here. Name paid user creator. Hold on, paid user creator, which is a function plus an object. Oh, hold on. Yeah, that's extended it. Oh shit. Okay. Now it gets interesting. I'm going to use a different color pen for everything that extends does. Okay. We haven't got many pens left. Shall I use our, yeah. Oh, actually, I'm going to use red. Yes, I quite like that sort of complementary to the pink for class. I use red, but everything that extends is going to do. Okay, first let's just get the regular stuff. So it's a function object combo. So its function is subtitled constructor. Subtitled constructor. There it is. And it has a property on its object portion, prototype. We know this is our regular stuff, which is itself an object, into which we're going to stick what function, David? Increase balance. And that's done for us now, rather than manually assign it there. It's just done by putting it in the class. Structure. It's a function. Okay. So what does extends do? Extends user creator is going to do two major things. We want any object that comes out of running paid user creator, which will be paid user 1. We want that paid user 1 to have a bond to this set of functions. Well, that makes sense. We know that. That's going to happen by using new keyword, running pages created. It'll get a bond automatically to the set of functions in a proto reference. No problem. But we want that object to also have access to this set of functions. So what, when it goes looking in here for say name, do we want to happen, Seth? When that object goes looking for say name in here, doesn't find it, we want it to go looking.
Its proto link should link up to it.
Perfect. Red means extends does it. So the first thing extends does is set that proto as a reference up to user created prototype. No problem. We did it manually before. Dot prototype.
With the object.create, to object.create, or using object.setup prototype off.
Up to that user created prototype. We did it manually before. Now extends does it for us. Extends automates that for us, and the bond is made up to there.
The functionalities.
But extends does something else. We want to, when we run page user creator with the new keyword, we want to run the constructor portion that we then want it to use the work we did earlier of assigning properties in user creator, to use that to help create the object with the right properties on it. Now remember we did that earlier? We used user creator with call and then we assigned to this. We ain't going to need to do that anymore. Now, inside of the function, the constructor bit, when we run page user creator, creates our object with the help of the new keyword, we're going to run super. And super is going to say, go run
the base class.
It's going to be a little bit finicky how it does it. We're going to see in a second. The spec explains it. I've only ever seen my favorite duality explain it explicitly. Otherwise, no one else explains it. The super is going to go and take us over to the user creator and run its function to create our object. And by the way, unlike here, where we made the object inside pages creator and then we mutated it one layer out, we're actually going to make the object, wait for this, we're going to make the object inside of user creator. But it's going to have its proto auto set to page user creator's functions. We'll see in a second. But that means there's one other thing that extends does. I can't. I'm not sure if you can tell this. It does this. It does this. It does this. It sets paid user creator, the function, its proto to the user creator function. To user creator. Just extend this down a bit here. Please, don't all laugh at once at my. Okay, let's extend that down slightly. The second thing it does is we have another property on page user creator, proto, that normally would just link to function.prototype, where all the shared, anything that a function has access to will be. This is the moment we go, and just give up. But it links up to user creator. We're going to see what it's going to let us do, people, is that when we run page user creator, the function, it's going to create us an object inside. We're going to call super, and that super is going to go, what am I? What do I need to go run? It's going to go look at proto, see user creator, and go run it, create our object. Promise one for a second, sir. I want to dive into this piece.
I'm kind of extending this piece a little bit. So if you left off constructor on page user creator, it's going to look in proto for constructor and just run constructor directly.
That's a different factor. If you leave on constructor, it's going to automatically put in a very simple constructor to return an object. So look, oh my god, look at what they call this a subclass, right? So it's not a base class, but a subclass. Look at what it has on it. That was just from, and everything in red was added by extends. One portion ensures that the objects that come out of running this function have access to these functions. That's what the proto bit on the function
Exactly.
ensures. The other portion, the other consequence of extends, ensures that the super, which when we run pages of creator,
Super can have a
run user creator to make the object there.
mixes from
That's
together.
that link is stored in the proto. That is where it's stored. If you overwrite proto, then the super goes, I'm not there anymore. When you call super inside of that, it is absolutely heading to proto and going to look up here. If you overwrite it with null, that super ain't going to do anything. Okay, let's see it play out. This is a lot of laying out. We're going to see it play out, and that should become a little bit clearer. Right, left-hand side here, Chris, what are we doing? We set up our whole paid user class with it as an extension of user creator. Now we're going to declare what?
Constant of paid user.
Perfect of paid user one, which we don't initialize or anything yet, while we go off and call paid user creator. Are you ready for this? I'm ready for this. This is our final code, folks. Paid user one is actually getting dark. This is a very bad sign. Okay. But yeah, this is our final code. We're like down to our final code. This is our final execution concept we're going to do tonight. Sorry. Let's pretend today. Alright, paid user one. Let's pretend for ourselves it is still today. Called with that mutative, that powerful new keyword, call paid user creator, pass in Alyssa 8 and 25. Okay, here it goes. Big execution context. There it is. Into it we go. And the first thing, wait, enough room there? Well, the first thing in local memory are our argument parameter complex. Let's have Michael help us out with those. We're calling pages creator. That means we run the pages creator function, which happens to now be called constructor as part of a class, but it is just a function here. And that says we're accepting page name, page score, account balance. So talking through the parameter argument matching here.
So the parameter matching here is like pay name. Exactly.
Yeah.
Which is the pay name, pay scoring, account balance, as Alice at 8 and 25,
And that, what am I thinking about? And now,
respectively.
Nick, this is your specialty area. What does this get us doing? Oh, I can't help you out. It's not your specialty area this time, because now in a class it does do something weird. So there is a this assignment, but it is uninitialized. Nothing there, okay? And we immediately must have a super call before we want to refer to that this. It is there, it's uninitialized, but we cannot refer to it. It's not undefined. We can't go console log above the super, which is hopefully going to go and call the user creator to create our underlying object. We are not going to run user creator and have it have a side effect on the this we create with a new keyword here. No, this fundamentally changes the class structure, how and where our pertinent object, the one we're creating, that will eventually be stored in page user one, is actually being born. It is not being born in pages creator. it is actually going to be born in user creator. And that is a design decision of the JavaScript team to make it be born in pages creator. Sorry, to make it be born in user creator construct function. It is born in there. And then it is automatically returned out and assigned to the this. Now, versus with the previous version, we had side effects.
We have side effects with that.
Okay, so let's start doing this. So we're going to call, so it's unassigned right now, uninitialized right now. We call super with what arguments, Chris? Which is,
And paint score.
which have what values?
Alyssa and
8. And they're going to go into as what parameter argument combos in the constructor?
score.
Name is going to be Alyssa, score is going to be 8 inside the execution context. Okay. Create the execution context. I'm actually going to do this. This equals, I almost want to say pseudo equals. We can't assign to this, behind the scenes is what's happening. This is going to equal the return value of calling super. Now, I'm going to actually show you briefly what actually happens. It does this. There's a new thing in JavaScript that allows you to call a constructor function, that's a function that should have a new keyword in front of it, that allows you to do it without the new keyword. It's called like reflect.construct. Can someone type that into Google? I think it's called, Mark, do you mind typing reflect.construct? It's in MDN. Reflect.construct. So I'm actually going to show you what this exactly does behind the scenes. I'm going to do it in red because it really is about the extent that makes this happen. Okay? So it's going to be reflect. Does it say reflect.construct exists? Yeah. Reflect.construct. Okay? Its first argument is
Reflect the construct. Static method is like the new operator, but as a function. Okay, to reflect. The reflect namespace object contains static. Okay, right now you're not able to see what I'm doing, which is this one. Why are you taking so long to do that? For real? What happened? Hello? For real? Okay. Okay. That's interesting. Go on. Okay. Get in. Good. So the reflect namespace object contains static methods for invoking interceptable JavaScript objects. Internal method. The methods are the same of those proxy handler. Unlike most global objects, reflex is not a constructor. You cannot use it with the new operator or invoke the reflect object as a function. All property and methods on reflect are static, just like the math object. Okay. So, but the reflect namespace object contains static methods for invoking intersectable JavaScript object. So the reflect objects provide a collection of static functions which have the same name as the proxy handler method. But this is after all an object that provide a collection of static functions which have the same name as the proxy handler method. Methods. Apply, construct, define, delete, get, has, own keys, prevent extensions, set, Okay. The major use case of reflect is to provide default forwarding behavior in a proxy handler trap. A trap is used to intercept an operation of an object. Exactly, something they call here is the interceptor, or a trap, as they call this. A trap, the function that defines the behavior for its corresponding object internal method. This is analogous to the concept of traps in operating systems. The term traps refers a processor mechanism for capturing and executing threats when an exception or an interrupt occur and transferring control to a fixed location in the operating system. Oh, a traps. Okay, a traps, or when a trap, when an exception or an interrupt occur in the execution threads. Okay, it's a process mechanism for capturing and executing threats when an exception of an intercept occurs and transferring control to a fixed location. Hey, there is an exception here. There is something that occurred here. Okay, so I'm going to now capture that and transfer to the execution, or transfer the control to another execution thread, or to another location. Pretty much like the interceptors. Okay, so but it's a mechanism for capturing an execution thread when an exception or an interrupt occur. I'm analyzing my code line by line, but this is a mechanism that I have that when an interrupt occurs or an exception happens when analyzing my code, hey, I capture that and I move the location, or I transfer the control to another fixed location in the operating system as a way to handle that. Holy moly. So that's a trap here. It's like, hey, it's a mechanism that while I am evaluating, what JavaScript is evaluating now is the execution thread, line after the another. Okay, when an exception happens, when an interrupt happens, hey, I'm going to transfer the control to a fixed location, to another locations to handle that. But in this case, this trap, the function that defines the behavior for the corresponding object internal method. Okay, so what are you gonna do? The functions, exactly, that define the behavior of the corresponding methods, of the corresponding object internal methods. And object internal methods, objects are collections of properties. However, the language doesn't provide any machinery to directly manipulate data stored in object. Rather, the object defines some internal methods specifying how it can interact with. But the language doesn't provide any machinery to directly manipulate data stored in the object. Oh, directly manipulate data stored in the object. Okay, the language doesn't allow that. Rather, the objects define some internal method to specify how it can interact with it. How you can interact with this internal data store. For example, when you read the object.x as it is, you may expect the following to happen. The x property is searched up to the prototype team until it's found, Okay, that's right. Hey, this exists in the object. No. So let me take a look now under the prototype change, or under the proto that holds a reference to the prototype property on the that holds a reference to the object. Okay, and if it doesn't have that inside of, if I don't have that property there, and then we're gonna take a look at the proto again that contains a reference to another object until that reference points to null, which means that this is it. This is it. Until it's found. If X is a data property, the property descriptor value attribute is returned. Exactly. And this is a hidden property. The property descriptor value, which is now part of this. If you take a look now at the ECMAScript here, as it is. Okay. ECMAScript here, specifically in the object. In the object here, as it is. Okay. In the object class object type, the terms here on the object. Okay, the property attributes here again, this is the property attributes. Okay, and object internal methods. Okay, this is the object internal methods, invariant of essential internal methods, and the well-known intrinsic objects. Okay, which is object that comes by default, built-in objects. Okay, but again is this data property value. So this is exactly what is describing here. If X is a data property, okay, the property descriptor exactly is X is a data property. For example here, exactly, is X is a data property, the property descriptor value, which is this, the property descriptor value is returned if X is an accessor property. One of them is the property attribute, and the other is an accessor property. Exactly, data property, and the other is an accessor property. Associate with the key with one of the two accessor functions and set Boolean attributes. The accessor function, one of them is the data property and the other is the accessor property. Okay. Associates a key value with one or two accessor functions and set Boolean attributes. The accessor functions are used to store or retrieve ECMAScript language values that is associated with a property. These accessor functions. Okay, the object type. So each instance of the object types also refers to simply as an object representing a collection of property. Each property is either a data property or an accessor property. And that's interesting. The property of an object are uniquely identified using a property key. The property key is either a string or a symbol. All strings and symbols, including the empty string, are valid as property keys. A property name is a property key that is in a string. Property attributes. Okay. if this is a data, oh my god, okay, if that property is a data property, so it will return the value of that. But if this is an accessor property, okay, if the value is an object, it must be a function object. Oh my god. So if the value is an object, it must be a function object. The function call, oh my god, this is an accessor property. An object or undefined. Default value is undefined. But if the value is an object, it must be a function object. Exactly. Similar for the get and the set. If this is an accessor property, which is a function, associate a key value with one of the two accessor functions. So if an x is an accessor property, the getter is invoked, and the return value of the getter is returned, because this accessor property has functions. Accessor property associates a key value with one of the two accessor functions and set Boolean attributes with one of the two accessor functions and set Boolean attributes. Get and set, because this is the characteristic of this. This is the anatomy of an object in JavaScript. Okay. The getter is invoked and the return value of the getter is returned. There isn't anything special about this process in the language. It's just because ordinary object by default has get internal methods, property internal methods, hidden properties, as I call it in the spec. Internal method that is defined with this behavior. The object X property access syntax simply invoke the get method, which is like this kind of trap here. Okay, invoke the get method of the object, and the object uses own internal method implementation to determine what to return. As another example, arrays differ from normal objects. Yep. As another example, arrays differ from normal objects because they have a magic length property that, when modified, automatically allocate empty slots or remove elements from the array. This magic behavior, that's right, or this magic property, because what it's doing is that automatically allocate empty slot or remove elements from the array. Similarly, adding arrays elements automatically change the length property. This is because arrays have defined own property. Similar, adding array elements automatically change the length property. This is because array have defined own property internal method that knows to update the length. If you take a look at the defined own property from the well-known intrinsic objects like arrays, and when you take a look at the indexes collection like the array, if we now look at the array iterator object, now property of an array instance like length, property of an array instance is a data property, okay, whose value is always numerically greater than the name of every configurable own property whose name is array index. Reducing the value of length property has the side effect of deleting own array elements whose array index is between the old and the new length value. However, non-configurable property cannot be deleted. Attempting to set the length property of an array to value that is numerically less than or equal the largest numerical own property of an existing configurable array index property of the array will result in the length being set to a numeric value that is one greater than the non-configurable numeric own property name. Properties on the array and properties on the array constructor. Now properties on the prototype here. Okay, exactly. This is to look at all of the prototype as it is. Okay, as well as the array constructor. Get methods. And the array constructor here, object. But because now arrays, I just want to take a look at this is the array constructor, property of the array constructor. That's right, is array. Okay, property of the array constructor. And the other is the array prototype add. And property of the array instance. Okay. Define own property. Is the initial value of array property of the object array. But it mentioned here that you have is this define own property, but I think define is a data property. Okay, it's a data property that has the value writable, get, set, enumerable, this property. But the length property of an array instance is a data property whose value is always numerically greater than that. Initially has the attribute writable, enumerable, and configurable. But you've defined here something called define on object. Define own property. But this is for internal objects. This is similarly adding array elements automatically change the length of a property. This is because array have define own property internal method that know to update the length. It performs the following step. Return ordinary define or property. the abstract operation ordinary on property takes an argument, which is take the object, the property, and the property descriptor, and return either a normal completion containing a boolean or throwback operation. Let the current be the object of prototype, get on prototype, let extensible be, validate and apply a property descriptor. Okay, validate and apply property descriptor. Validate and apply the property descriptor. Okay. But we were looking at this. Internal method has known to update the length when an integer index is written to, or update the array contents when the length is written to. Such object whose internal method has different implementations from ordinary objects are called, such object whose internal methods have different implementations from ordinary objects are called exotic objects. Object whose internal methods has different implementation from ordinary objects are called exotic objects. So you have a different implementation from this ordinary object, from this base class. Okay. Proxy enables developers to define their own exotic object. So proxy allow you to define your own exotic objects. Allow you to define is internal methods allow you to define internal methods with a particular behavior from ordinary objects. Okay, so this what allows you is to define is internal method with a particular behavior. The proxy would allow you to do this, which is also called as exotic objects. There are objects that internal methods has different implementations from the object, from the ordinary objects, from the base objects. And proxy enables developers to define their own exotic object with full capacity. And proxy enables developers to define their own exotic object with full capacity. All object has the following internal methods. Exactly. And how you can get that? Well, by looking now at the objects, ordinary object internal method, like this. Ordinary objects internal method. Get property of, set property is extensible, prevent extension, get our property, define on property. As a way to update is the value of this, and as well as it is behavior. And in the case of the array, length, when you change that, it'll now have its own implementations from these ordinary object. That's what they call an array an exotic object. Because it is internal method has a different implementation of an ordinary object, of a base object. And with this, if you can apply that now to the class, you can now apply some of this internal behaviors. We can apply some of these internal behaviors, or we can define some internal. We can define some internal methods that are different that have a different implementation from an ordinary object. And because here reflects is a namespace objects containing static methods for invoking interceptable JavaScript objects internal methods. Oh my freaking god, bro. This is a way of how you can now intercept this internal methods. Oh shit. This is how you this object allow you to intersect internal methods and do something about it. So unlike most global object, reflect is not a constructor. It's an object that contains static methods for invoking intersectable JavaScript objects internal methods. Okay, so this is an object that you're going to define. This is an object that will allow you to define is this is an object that will allow you to define or that contains static methods. Okay, this is an object that contains static methods to invoke internal method for invoking interceptable JavaScript object internal methods. The methods are the same as those of proxy handler. So if you have now this object that anytime you now if you have this object that expose or that contains this static method that contains a static method for invoke reflect for invoking intersectable JavaScript object internal methods. Holy moly, so all of these internal properties here that are defined in the language, okay, whether it's from an object or from exotic objects like arrays, and they call exotic object is because the internal method has a different implementations from the ordinary object, okay, as a way to extend its functionality to provide some particular functionality to this from the normal object to make this for example this new object. So objects, normal objects, has a set of hidden properties, normal ordinary object has hidden properties, hidden or internal methods, method that you can method that you can have access, but most of the time we don't touch them. So for example, get prototype off, set the prototype off as a way to give me is the reference of the prototype change. Now set the reference of the prototype change. Prevent extension, get on properties, has property. Okay, so now this, oh my god, so now this objects here, for example, cons user, when you say, hey, this is the name Arthur, and the coins, or you can say is the balance of 20. So now this user has internal methods that you can go with. So for example, has on property that are defined here. Okay, has property. What we can say is get okay, but there are internal methods. There are internal methods. It has internal methods here, but it's the object itself. Ordinary object internal methods and internal slots. Define getters and define setters. And the proto reference, which they call this the proto. So define getter or lookup getter. And you can see this is the way how they define this as it is. Lookup getter. But it has all of this inner property, ordinary object create. Okay? It has all of this inner object here. Get prototype off, set prototype off, is extensible, prevent extensions, get on properties. So the object itself contained is all of this internal method, hidden methods. For example, like get off property, get prototype off, as a way to know what is the prototype link from the user. Okay, and it tells you, hey, the reference that I got here, or the parent class, is the object itself, where it points to null. Okay, but you know, this is how you can now take a look at all of this internal methods. Makes a lot of sense. You can say, hey, this object has on or has property. Again, the specifications change according to implementations in the case of the browsers, but say has on property here. So if this object has on property, yeah, has on property. Get on property, you can look at it like this. Say get on property. Get on property. Get on property names. Get on property names of the user. Okay, so now you can have is the property of these objects. Okay, give me only the objects of this array. Give me only the keys of this array. Okay, give me only the keys of this array. Give me now object on property descriptors. of the user. And it tells you is now, hey, balance is an object that contains this, as well as the name for that. That's interesting. So the object now here is all of these hidden properties. So hey, freeze this object, define property here, define properties, get on property names, get on property symbols, has on, and also it exposes the group by user not sure how to use this, by the way. Object group by, object group by. Oh, this is an iterable, and it's because it's new, bro. Oh my god. The items and the callback. Because this is an iterable, such as an array whose element will be grouped. Object group by. Can calls provide a callback function once for each element in an iterable. The callback function should return a string or a symbol. Values. String or a symbol. So from this, object group by the iterator or the element. So I want you to now group them by, holy hell. I want you to group them by a particular value here from type. And in return you is that, okay, this type vegetables now contains is here. Now this, okay, as a way to group by. Interesting. Hey, I want you to group by type. I want you to group by name. And you're gonna give you now is per values all of this. That's lovely. The arrow function just return the type of each element, because you are effectively creating a closure around that. It means that the value of this will be now enclosing to this, to the inventory, object group by inventory my callbacks. Exactly. Hey, from the inventory I can pass now a callback here to say if this actually fulfill a condition. Quantity, okay, and if the quantity is greater than 5, say okay, otherwise restock. And then you're going to return is now this object that contains restock and okay with this. Holy moly. Oh my god. Thanks for doing this, because actually doing this kind of logic as a way to group object like as it is a task in itself. Similar to accessing data to a collection of values, it's a task in itself. Holy moly. So because now this reflect has is an object, it's a namespace object, which means that it contains all of these static hidden properties, or it contains all of these static methods for invoking JavaScript objects internal methods. All right. So now it is using behind the scenes is reflect. Unlike most global objects, reflect is not a constructor. You cannot use it with a new operator or invoke the reflect object as a function. All properties of the objects of reflex are static, just like the math object. The reflect object provides a collection of static functions, which we have the same names as the proxy handler methods. The major use case for reflect is to provide default forwarding behavior in the proxy handler trap. A trap is used to intersect an operations of an object. It provides a custom implementation for an object internal method. Hey, I want you to know behave. I want you to customize is the implementation for one of these internal methods that you have. The reflect API is used to invoke the corresponding internal method. For example, the code below creates a proxy P with a delete property trap that intercepts the delete. Okay, the reflect API is used to invoke the corresponding internal method. The reflect API is used to invoke the corresponding internal method, which have the name of the proxy handler methods. So it contains all of this. This section lists all the handler functions you can define. Handler functions are sometimes called traps because they trap calls to the underlying target object. The reflect API is used to invoke the corresponding internal methods. For example, the code below create a proxy P with a delete property trap that intercept the delete internal method. Reflect.delete property is used of the object internal method. Okay, yeah, we have the delete. Okay, the delete. The delete property. Interesting. Of the target object property here. For this new object that I'm going to create, the delete property, I want you to now custom function log deletion. Execute the default introspection behavior. And execute the default introspection behavior. Okay, that is static method. Hey, I want you to now run this. So if I do this for this, it's some sort of like a middleware or traps. So anytime I add a new property here, let's say name Alice in balance 20 in gender female, and then you say, hey, I want you to now delete the b dot gender. You're going to trigger this particular behavior here, deleting property gender. Oh my god, this is, you have now much more fine control about what's going on in this particular object. You are now have much more control of what's going on in this object as a way to keep track what's going on behind the scenes. That's something interesting, because now Vue is using proxy as a way to detect when it needs to run a particular update, okay, because after all, Vue is just a rendering system, okay, unlike React, which is just to render component, just to render function, not a rendering system. And because of that, makes a lot of freaking sense, bro. It's all about JavaScript. It's all about JavaScript, bro. They have a particular way of doing this thing, whether it's with Vue or with another. They have a particular way of doing this. Holy moly, bro. Holy moly, bro. That's interesting. So the thing here is that they might be using a property called reflect as a way to intersect when you call is this internal method, for example, set prototype, okay, as a way to update the proto reference, set prototype, set prototype, okay, as a way to now is ordinary set prototype off, okay, let current be o prototype, ordinary set prototype off. Let current be o prototype if same value v current is true, return true. Let extensible be o dot extensible. It's a prototype internal method, an ordinary object here that takes argument v and an object of or null and returns a normal completion containing a boolean. It performs the following step when called. Return ordinary set prototype off. The abstract operations here. Holy moly. So this reflect that has is all of this hidden, is a namespace of a static method of the JavaScript internal methods, okay, the reflect makes a lot of sense. Okay, so it's a namespace of object containing static methods for invoking intersectable JavaScript object for intercepting, for invoking interceptable, because this is something that this object allows you to, for invoking interceptable JavaScript object hidden or internal methods. Holy shit! Like this, it allows you to. So this is a bag. In other words, it's a bag of static. It's a bag of static method for invoking interceptable JavaScript object hidden or JavaScript object internal methods. So for example is, well, set the prototype for that. I'm assuming that. Set prototype here. Mother. So what class is doing behind the scenes, this function constructor is using is a reflect as a way to say, hey, when this happen, okay, when this happen, I want you to invoke is this. I want you to invoke now this. I want you to invoke is now this. Exactly, for the object to the object prototype. Return a boolean if set the property of a specific object. Exactly. God damn it. Jesus freaking Christ, bro. Holy fuck.
It's the function that's going to be creating the object. What is the function going to be creating the object? It is user creator, because it goes to look for proto and it's user creator. This is just what it's doing behind the scenes. User creator, and then the arguments. Alyssa, I promised myself not to do this bit, but there we go. And then the function whose prototype object we want to have the returned object that comes out of the call to super point to, which is paid user creator. So paid user creator, paid user creator. But for our purposes, and then that returns out an object into this. But for our purposes, just think of it as the super. We can write it a couple of ways. Think of it as the super being. Super goes, oh no, what do I want to run to produce the object? Well, the object I want to have is the user object, but we're going to add a bunch of stuff to it. So go run the user creator constructor. How do we know to go run that? Because extends put in the proto a reference to the user creator function, the user creator constructor function. So super goes, no, what super? You can almost think of it like this, that in local memory, super is set to user creator. Not literally, but you can almost think of it as super is set to user creator. Okay, so super is set to user creator, called with Alyssa, and 8, and then that's going to be stored in this. These are just 3 different ways of saying the same thing. Don't worry too much about this reflect.construct thing. It's just a new way of allowing us to, and behind the scenes is really what's happening. We're running user creator with, the new keyword in front of it. It's going to return out the object that we know well and love, but we're going to control the returned out object proto to not be to user creator prototype object, but instead to be to paid user creator prototype object. Okay, let's just do it. That's not what I regret bringing that reflect.construct thing, but just know that what we passed in last there means that this running of super user creator is going to set the prototype to be paid user construct thing. But just know that what we passed in last there means that this running of super user creator is going to set the prototype to be paid user creator dot prototype, not user creator dot prototype. Here we go. So super refers to. Here we go. So super refers to. Let's go run user creator. Just like we did before. Go run user creator. Make the object, but before we used that previous work and applied it to the local object in paid user creator. Now we're going to make the object inside of user creator, not inside of page. And we're going to return it out into page user creator. Let's do it, and then we're done, people. So calling super, really cool to user creators. Constructor function. Let's have Nick. Save me, Nick. We're calling super. It's really user creator with the new keyword in front of it. Its output is going to be stored in this in page user creator. Talk me through the execution context of user creator with the new keyword. Help me out, Nick.
So the new keyword.
Let's just do our arguments first.
Arguments.
So our arguments are.
Our arguments are name and score.
Those are our parameters with the arguments.
Oh, with the arguments Alyssa
Yeah.
8.
Perfect. Hold on. Alyssa is our argument assigned to our parameter name, and score, and then score is 8. It's the being called with a new keyword, because super is really calling user creator, the constructor bit, with a new keyword to make the object, but no, we're making it inside of here, right? Not out here. Okay, so let's do the new keyword stuff. Go ahead.
So new creates a this, empty this object,
Beautiful.
which gets set with a proto.
To where? Normally it would be to user creator dot prototype this object here, wouldn't it? But by the nature of the class design, the super sets this object's proto not to the function user creator dot prototypes object. Instead, it overrides it. And David, where does it set it to? Page user creator dot prototype. Fantastic. And that's what I was regretting bringing up, but sort of showing you under the hood what's happening. It says rides it. And David, where does it set it to? Page user creator.
Page user creator.
Fantastic. And that's what I was regretting bringing up, but sort of showing you under the hood what's happening. It says run user creator with the new keyword, pass in these arguments, and set the returned object proto to page user creator dot prototype. That's all. This is a new way of doing stuff in Java. Creator with the new keyword, pass in these arguments, and set the returned object proto to page user creator dot prototype. That's all this. This is a new way of doing stuff in JavaScript in ES6 that allows you to manually control more of what the new keyword does. That's all it was. We can see without bringing it up. Give me bring that up. It's worth. It's an interesting thing to see as a new way of doing this stuff. But yeah, we now set our proto. Remind me again, Nick.
That allows you to now have much more control about the new keyword.
Prototype that object. Yeah, exactly. Let's just draw the line through. It's a long way. Can I get my line? There it is. And that object is going to have what properties added to it, Nick?
Name and score set to the values of Alyssa 8.
Beautiful. Name and score. This is our final code. It's great, but it's stuck inside of. So 1 was this is the object. 2 was proto was set, but proto was set in a really interesting way. Right. And 3 is to do what, Nick?
It's returned to the constructor of page user creator.
Fantastic. To its execution context in what local in what
This object.
in the this exactly. It goes and sticks in the this. Fantastic. But folk, it was even a revelation to me, as it even, probably especially, a revelation to me, that is awful, I apologize. It was a revelation to me that the construction of the object itself is happening in the user creator constructor and then getting returned out. Fantastic. But folk, it was even a revelation to me, as it even, probably especially, a revelation to me, that is awful, I apologize. It was a revelation to me that the construction of the object itself is happening in the user creator constructor.
The base class.
Being returned out.
And then get returned out.
Okay, the construction of the object itself is happening in the user creator constructor and then getting returned out one level. Okay, where it is returned with name, Alyssa, score. It was a revelation to me that the construction of the object itself is happening in the user creator constructor and then getting returned out one level. Okay, where it is returned with name, Alyssa, score, 8, and then proto.
So here is that. That's exactly what the extend is doing.
Okay, let's just get rid of it from here. Let's just say here it was up to.
Or the supper.
Now we can see where it actually links up. This is horrible. I regret this. Can we get my purple line?
Is calling that new function constructor from then that is actually setting is the value of this for that.
Go. And now what do we add to this object, Nick? Oh, that was in our prototype easy slip to make. Account balance with what property value? 25. Good. And to our last online member who's still with us, because they can leave the room anytime. That is the blessing of being the online audience. Anytime they can leave the room going, it was good. Next time. We grab this object. We're calling page user creator with the new keyword. So, Nick, we've got our lovely object here in the this. What do we do to it automatically?
We return it to.
We return that
Nick, I'm
this.
so impressed. Out it comes. There it is. Into page user 1, where we find final piece where we find name. Seth, stop packing your stuff up. I can literally hear the zip of your bag, Seth. Okay. And the proto is continuing.
Stop packing your things up.
So here we go. Our final lookups. Our final lookups. I'm actually out of breath from so much excitement. Excitement. All right. I really don't know why I brought up this version, but it should show you what the new keyword's really doing in this situation. It's slightly different here. Moving us on to a different. I really don't know why I brought up this version, but it should show you what the new keyword's really doing in this
What the new keyword is doing?
situation. It's slightly different here. Moving us on to a different portion. And that's actually what's happening behind the scenes. I thought that's very cool as well. Okay, so let's do our final lookups. Remembering, all we want is a paid user 1 who has access to the paid user specific functionality, but also to
the user functionalist.
And that paid user 1 has the properties of a regular user, and we didn't have to go and redo this property sign. We just used the constructor that made the regular user earlier. And funnily, with the class model in the new ES6 version, you do the creation of that object in user creator and then return it out to paid user creator, which seems reasonable, but it is different to how we used to do it canonically in pre-ES6, pre-ES715, where we built it out here and then had side effects to change it using the previous constructor function. Paid user 1 .increase balance, let's call it Elliot. It is your moment, man.
We look for a paid user 1.
Hold on. Paid. Look up, we look. By the way, user 1, if we went looking for every single kind of in paid user. It's a little bit, I mean, this was the emerging standard until ES2015. And I can tell you, it's a little, we controlled every single piece of it by hand, which I like this. I know exactly what I'm doing here.
Exactly. I know exactly what's happening here.
I'm manually setting bonds to them, no problem. Then we said new keyword. Do some of that connecting up automatically. You know what? End up doing some sort of weird connecting up.
It's weird connecting up like that.
Use that function over there, user creator, and we wanted to use it, but we had to kind of play with it by setting the this to be the this one layer out in paid user creator, so that it referred to the right object that we were making for a paid user. That was a little bit of a mess. Sorry, don't go ahead. And then update proto. That was a little bit mess. Well, we update proto on the paid user creator's set of functions, so that they had a link to the user creator's set of functions, the user functions. It's a little bit. I mean, this was the emerging standard until ES2015, and I can tell you, it's a little bit. I don't know. It's a little bit almost hacky. Not literally.
It's like quite odd.
It kind of gives you some stuff and then takes away. It gives you some stuff and too much, and you have to kind of do adjustments. I will say there's a solution for. It is now fairly clean of an implementation. But under the hood.
But under the hood, oh my god.
Praise, you've been in a kind of zone and artistically you look back and you're like, shit, what happened here? So solution 4, it is cleaner. I mean, the code is pretty clean.
Exactly.
But to debug it effectively, we have to still know that all of this is going on under the hood. Imagine you came to JavaScript from Java, and you thought this was emulating Java or Python under the hood. I mean, you would just be left with a complete blank and a complete inability to go and actually debug and write clean code long term. We now have, I hope, the tools under the hood to know exactly what a class is, to know exactly what its gens is doing, and where it comes in with super, and where it comes in with our proto reference to our prototype object, with its proto reference to this prototype object. We know every last piece. So, well done, folks. This was even more demanding than hard parts, the new hard parts. But it's pretty demanding. But I'm very, very impressed you all followed along. So thank you so much. Thank you to our wonderful online audience. It's been a pleasure having you. If you did stick it out, and I know some of you are around the world, and it's now the new early morning in Indonesia, where I know some of you are, it has been a delight to have you on as well. So thank you so much, everybody. And now, we wrap. Thank you, everybody.
Holy moly. Well, that'll be all for this video. Take care. Bye-bye.